Okay, so section 4.3 is on derivatives of inverse trig functions. All right, this is not super important on the AP test, but there are a few questions on this, so this could be the difference between a 4 and a 5 on the AP test, so good things to put on note cards. All right, so it says, if you recall from pre-calculus, the inverse sine function, or the arc sine function, is restricted to the domain negative pi over 2 to pi over 2. Do you guys remember talking about that in pre-calc? So basically, oh, does that wig you out? Basically, you have the sine function. Looks like that. Here's 2 pi, here's pi. All right, and basically you need for it to be 1-to-1 in order to take the inverse of the sine function. Remember, we talked about what 1-to-1 means. It allows you to take the inverse. And your calculator, whenever you do arc sine, it only gives you one value. You know, arc sine or inverse sine, same thing. So the reason is because it restricts it on this domain right here. Do you guys remember what 1-to-1 means? It passes what test? Horizontal line test, right. So see how that part that I've just marked in red, it passes the horizontal line test. Okay. If I had put it from 0 to pi, so if I tried to restrict it from 0 to pi, that part does not pass the horizontal line test. Because if you draw a horizontal line, it goes through more than one point. All right, so that's why we've drawn it between negative pi over 2 and pi over 2. So basically, when you're using inverse sine on your calculator, you get values that are between negative pi over 2 and pi over 2. Okay, those are the only values that's going to give you. All right, so we say inverse sine of x equals y if and only if sine of y equals x, and that y value is between negative pi over 2 and pi over 2. Okay, the cancellation equations for inverse functions are inverse sine of x equals x, when x is between negative pi over 2 and pi over 2, and inverse sine of inverse sine of x equals x for x is between negative 1 and 1. Okay, kind of confusing. Okay, I think this should actually be, I need to go back, but this should be from negative 1 to 1. Y values between negative 1 to 1. Okay, so basically when you're inputting things into inverse sine, your input has to be between negative 1 and 1. Why does that make sense? You guys understand? It's the inverse. So what was special about sine values? Sine values are always between negative 1 and 1. So inverse sine values, your input has to be between negative 1 and 1. Remember how you switch your x and y values? Confusing. All right, so the inverse cosine function or the arc cosine function is restricted on the domain. So think about it. Where is it going to be restricted? So if I have cosine. Oops. Here. Pi. I have to think of it with a unit circle. So pi is 0. 2 cosine. What am I doing wrong here? Hang on. So cosine of pi is negative 1. It's down here. This is pi over 2. That's pi over 3. Okay, so so where is inverse cosine restricted? So where is it 1-to-1? 0 to pi. Do you guys see it? This is where it would be 1-to-1. You can't use negative pi over 2 to pi over 2 because then that would not be 1-to-1. All right, so when you use your calculator and you're talking about inverse cosine, it's always between 0 and pi. Okay, so question, why does inverse sine of pi over 4 equal pi over 4, but inverse sine of 7 pi over 4 not equal 7 pi over 4? So let's think about it. So let's go from the inside and work our way out. Okay, so I have inverse sine of pi over 4. What is the sine of pi over 4? what? Root 2 over 2. So what we're saying is on our sine graph, where is the y value equal to root 2 over 2? Okay, but you're restricting it from here to here. If you guys are familiar with the unit circle, you're restricting from negative pi over 2 to pi over 2. That is this side of the unit circle, the right side. So where do you get a height on your unit circle of square root of 2 over 2? At pi over 4. So that part is equal to pi over 4. Okay, now we're going to work on the other one. So I'm going to do inverse sine of 7 pi over 4. What is sine of 7 pi over 4? Close, not root 2 over 2. What is it? I can't hear you guys. Louder. No? Sine of 7 pi over 4. Where is 7 pi over 4 on your unit circle? Right here. What's your y value? Negative root 2 over 2. So now you're saying on that restricted domain, so from negative pi over 2 to pi over 2, what is inverse sine of negative square root of 2 over 2? Kind of a trick question. What is it? Not 7 pi over 4. Because you're on this restricted domain that's between negative pi over 2 and pi over 2, and 7 pi over 4 is not on that domain. Negative pi over 4. Thank you, Mackenzie. Do you guys see that? Your answer can only be between negative pi over 2 and pi over 2. 7 pi over 4 is not in that domain. Now, it gives the same coterminal angle. Do you guys remember talking about coterminal angles? Like this angle right here is negative pi over 4, but it's also 7 pi over 4. I mean, those are the same location, but we're talking about that restricted domain from negative pi over 2 to pi over 2. Okay, that's why they are not equal to each other. That's why you can't just use the cancellation property. And I never really fully understood that when I was in school, that you couldn't just cancel those out. Okay, because inverse sine is only on that restricted domain. Okay, so 2, find the derivative of y equals inverse sine of x by changing the form of the equation and differentiating implicitly with respect to x. Okay, this is kind of a weird one. I'll see if I remember all of it. Okay, so I'm going to switch it to sine of y equals x. And I'm going to differentiate. So the derivative of sine of y is going to be cosine of y times dy over dx equals 1. So dy over dx is going to be 1 over cosine of y. Okay, but I don't want y to be in my final answer. Okay, I'm not going to do cosine of inverse sine of x either. It's kind of weird. Okay, so here's what we're going to think of. On your unit circle, you know that x squared plus y squared equals 1, right? Makes sense? You guys know why? This little right triangle. 1 is the hypotenuse, x and y. Okay, so x squared plus y squared equals 1. Okay, so we need to somehow talk about what cosine of y, how we can replace that. Gotta remember how I do this. Okay. I have to think. I have to look this one up. It's been a while. Okay, so we have y is any angle. So since we're doing sine of y equals x, y, we said it was restricted. Keep getting the wrong thing. Okay. So y is between, remember sine is always between negative pi over 2 and pi over 2. Okay. So y is some kind of angle. So we know that cosine squared y plus sine squared y equals 1. Okay, kind of what I just told you over here with the unit circle. Let me erase it so I have more room. I mean, that's Pythagorean identity. We know that should be true for any angle, right? All right, so if I'm solving for cosine of y, I'm going to subtract the sine squared y over. And I'm going to take the square root. So I'm going to get plus or minus the square root of 1 minus sine squared y. Okay, let's think about it. So on our unit circle that I have drawn up here, so see where I'm circling? Okay. We know y is an angle between negative pi over 2 and pi over 2. So cosine values are between, do you guys see that cosine values, so you're on the right half of your unit circle. So your cosine value is going to be between 0 and 1. So that means that cosine has to be positive. So say something like on right side of unit circle. So cosine y is positive. So we're only dealing with the positive part. Okay, and then the last step is sine of y. What was sine of y originally? X. So you have positive square root of 1 minus x squared. I keep doing plus or minus. Positive square root of 1 minus x squared. So that means the derivative in terms of x is 1 over square root of 1 minus x squared. That's what the derivative of arc sine of x is. Kind of weird. You would think that it would be something with like cosine or something weird. Okay, so let's repeat the process for cosine. I know. Okay, so we have cosine of y equals x. So when I take the derivative of cosine is negative sine, so I have negative sine of y dy over dx equals 1. So I get 1 over negative sine y. So negative 1 over sine y. Okay, cosine is, so inverse cosine is restricted, well, x is restricted to where? 0 to pi, right? Is between 0 and pi. Okay. So that means y, that was y, is between 0 and pi. Okay, so our angle's between 0 and pi. So where on our unit circle is between 0 and pi? The top part. So top of unit circle. Okay, so let's do that same thing. So let's write cosine squared plus sine squared equals 1. Or sine squared plus cosine squared, doesn't matter. And think about how you would solve for sine y. So I'd solve for sine of y by subtracting cosine squared and then taking the square root. So I'm going to have sine of y equals plus or minus the square root of 1 minus cosine squared y. But since we're on the top part of the unit circle, sine values are always positive, right? So you're going to use the positive version for that. Okay, so your final answer is dy over dx equals negative 1 over, and we said sine of y was the positive version, so 1 minus cosine squared. Oh wait, not quite. What's cosine y? Go back to your beginning. X, so 1 minus x squared. What? One minus what? I don't know what you're saying. Okay.
So I shouldn't say it all.
Okay. So here are your derivatives. Yes.
So it's minus x squared over cosine equals x. So
Yes, cosine of y was equal to x. So just replace the cosine y with x.
and it's negative 1 at the top.
Because it was the derivative of cosine was negative sine y, so I divided by a negative. So there, right, there's a negative. Okay. All right, so here are your derivatives. Like I said, they're not like always really important on your AP test. Last year I made last year's class like memorize these and know them because they've always been there on there in the past, and then they weren't on there. So I'm not saying they're not going to be on there this year, but they told me that they didn't see any arc cosine or arc sine or anything like that on there. One of the reasons for that might have been it was a new test last year because you were not penalized for having incorrect answers on your multiple choice. So maybe they just switched it up and decided that they didn't want these on there. I don't know. All right, but the most important ones, the ones that I see in the past exams, would be inverse sine and inverse tangent. So those ones are the most important. So these are definitely major flashcards. The other ones are probably flashcard worthy, but I would definitely know the inverse sine and inverse tangent. Okay, on your in-class exam, those would be the ones I would choose from. Wink, wink. All right, so number one, so differentiate y equals 1 over inverse cosine of x. So I have y prime equals, I have to use the quotient rule because it's 1 over. You could also do chain rule by raising it all to the negative 1, which is very confusing having an arc cosine raised to the negative 1 power. But you guys all know that this does not equal 1 over cosine. You guys all know that, right? Yes. All right. So I have low d high, so derivative high is 0, minus high d low. So look up for inverse cosine. The derivative of the lower piece is negative 1 over the square root of 1 minus x squared, all over the square of what's below. Kind of messy. I have positive 1 now over the square root of 1 minus x squared, and I'm dividing by inverse cosine squared. So your final answer is multiplied by inverse cosine squared. So it's going to be 1 over inverse cosine squared times the square root of 1 minus x squared. And that's how you would leave your answer. A little scary. Okay, number 2, find the derivative of y equals x arc sine x. Okay, so when you see arc sine, that's just the old school way of writing inverse sine, like sine to the negative 1. So if you want to see it written like that, that's fine. I think they used to do that because it's hard to like type and write exponents, so I think they always just called it arc sine. Okay, so I have y prime. I have to use the product rule. So first times the derivative of the second. So if you need to look back, remember we derived that, but it was 1 over the square root of 1 minus x squared. Plus derivative of x is 1 times inverse sine of x. So you get x over the square root of 1 minus x squared plus inverse sine of x. And that's your answer. Notice I only had 2 examples. That tells you how important I think this is. Not very important. You only have 1 question, so number 24 on your take-home test that has to do with this. So they aren't super important, but you never know, they might appear on your AP exam on the multiple choice section or something. All right? Oops.